This video is on 10 reasons why amino acids the best option to have started life. Number one, they're everywhere. In every carbonaceous meteor we have tested, they've had amino acids. Any number of chemicals you mix and react with heat and electricity forms amino acids. Anytime that you look anywhere, you find amino acids. There's billions of tons falling every year from outer space into the atmosphere, and there must have been billions of more amino acids bombarded on the Earth during the late heavy bombardment, which most astrophysicists believe brought the volatile chemicals like water, hydrogen, carbon dioxide. They come in 500 different varieties. Of the amino acids we've tested on these carbonaceous meteorites, there was 500 different types that we identified. Now you can very surely agree that in 500 there has to be a representation of every element in the periodic table that could be found as an amino acid, which would make it very easy for prebiotic life to incorporate and utilize whatever element they need. They can find it in an amino acid. They keep their chemical integrity. When amino acids link and they get next to each other, they interact, but they don't form permanent bonds. When you put the conditions where they'll stretch out again, change the pH, they'll continue to have the same conformation. That's not true with physical chemical elements, because they either crystallize or they permanently bond to each other, and the conditions that cause them to bond to each other won't be the same conditions to disassociate them. There's going to be completely different. You're going to need completely different conditions to separate those bonds. So it would not be beneficial to use inorganic chemicals to form regenerative or cyclic processes. Amino acids lend themselves to that very easily. And speaking of that, they form spontaneous hydrogen and sulfur bonds, which help them become more rigid and stabilize, and help them maintain a structure that benefits their reactions to each other and to other amino acids. The great thing about that too is that when the conditions and the pH change, the proteins or polypeptides dissociate, and those spontaneous hydrogen and sulfur bonds separate and reform somewhere else. But if you change the pH back to the original conditions, of course after getting them high enough to disassociate completely, when you put them back to the original conditions of the protein where it forms its original conformation, those hydrogen bonds and sulfur bonds reform in the same location, returning the catalytic chemical reactions that polypeptide or protein were doing at that time. Unlike inorganic chemicals, the only solvent that amino acids require is water. Every single amino acid is soluble in water. Now there are some that are less soluble and are been deemed insoluble, but when you compare the molecular weight of an amino acid and its ability to be soluble in a certain volume of water, although it doesn't dissolve as much as other amino acids, a very small portion does. And that small portion is no small portion. That is trillions of molecules of amino acids in that water. It's not at a level that we, being fumbling around with chemicals, we can't work at the molecular level. Nature does work at the molecular level. It can use one single amino acid to form a bond or chemical reaction to something else. It doesn't need to be completely dissolved in water for that amino acid to work. Those amino acids still will be available, albeit not as much as the other ones, but there'll be enough in a certain volume to assist in any reaction that requires that amino acid, so that all amino acids are soluble in water. I don't care what anybody tells you. The other thing is, it doesn't only need water. It needs carbon dioxide and water, which forms a very weak acid. And a weak acid is very conducive to the reactions of amino acids to each other, with each other, and reacting and causing catalytic reactions. That's all it needs. It doesn't need any exotic conditions. It doesn't need any exotic solvents to cause these reactions to take place and give us the products we need to start life. Amino acids in the form of proteins react with other amino acids to create the products that life needs. The other thing is, given that amino acids will be in water with carbon dioxide, which carbon dioxide was extremely abundant in the Hadean era before prebiotic life. Prebiotic life. Life before there was, in the conditions of the earth prior to life, there was an abundance of carbon dioxide because most of the oxygen was not available. It was either oxidized into chemical reactions or in carbon dioxide in the atmosphere. But that was perfect conditions to allow amino acids to bond to each other. You will never find amino acids in a singular state. They need to be bonded to something else. So, and the usual is each other when you get them pure in the pure form. You'll never find an amino acid alone. They'll bond spontaneously to each other, which is conducive to polypeptides. And polypeptides in simpler life forms are what simpler life forms use to form larger proteins. Most enzymes in simpler life forms are polypeptides that join together. My example that I love to go to is E. coli, which is available in our guts and is a workhorse of biotechnology today, which is the bacteria that we modify to produce the proteins we need. That that bacteria uses 12 polypeptides that unite to start the process of changing an amino acid to a precursor of RNA. 4.5 billion years later, that is still a means of creating RNA. 12 polypeptides bonded together to start the process of changing an amino acid to an RNA. So that would have been very easy to have occurred in the Hadean era prior to life. Amino acids, when they're strung together in polypeptides, spontaneously form structures, either alpha helixes or beta sheets. And the combination of alpha helixes and beta sheets in larger proteins is what creates active sites for enzymes to do their job. So the fact that they spontaneously form these structures is another strong indicator of the ease of amino acids forming useful structures that would start life. The other thing is that all biomolecules are made from amino acids in life. Any There's a reason why when we digest food, or any life form digests food, they don't break them down any further than amino acids. They take those amino acids, they spread them throughout the body, and the other cells absorb them and use those amino acids to start modifying them to become precursors to form sugars, which is a surprise to me. Recently I discovered that. Fatty acids, and precursors to DNA and RNA. So everything life needs can be brought about with amino acids. There's no need for these exotic chemicals that we're not sure. I personally don't believe they would have existed for very long because they're extremely reactive. Those chemicals that they hypothesize that would have been present at the origin of life, how long would those chemicals would have been available for life to use? These are highly volatile inorganic chemicals that I don't think would have stayed in an active state long enough for life to utilize and form RNA and DNA. The other thing, they are weakly bonded. Again, it goes back to what I was talking about, that once inorganic chemicals form a bond, the conditions that allow those inorganic chemicals to form that bond will not be the same conditions you need to separate those bonds. In order to separate those bonds and break those covalent bonds, you'd have to get conditions that are extremely different than the initiating conditions that created that bond in the first place, which is not conducive to how life works. Life works in cyclic systems that can go backwards and forwards, and you can reutilize the chemicals you used before and repurpose them. That's what life does, and that's exactly what amino acids do. They're weakly bonded, which normally would be a detriment, but in this instance, amino acids being weakly bonded to each other is a benefit, which will allow them to be recycled, be reused, be easily changed from one form to another. So that is a benefit, not a detriment. Again, something that makes them extremely easy, like Legos. They can work, put together, and taken apart very easily. And then the big thing, number 10, the catalytic action and the enzymatic action of enzymes is 1,000,000-fold greater than inorganic catalysts. Inorganic catalysts, catalytic reactions are 100-fold, meaning that the reaction that they help 100 times more, make it 100 times more possible to occur than without the assistance of the catalyst. When it comes to organic enzymes, they help reactions occur 1,000,000 times more, making it seem like if you had a match which represents inorganic catalytic reaction, enzymes, protein enzymes, are like laser welders compared to a match in the enzymatic properties of amino acids when they form enzymes. So again, something that is much more beneficial to life would make it much easier for amino acids to start life, because they can form that cyclic reaction to bond to each other, spontaneously form hydrogen and sulfur bonds, which help them become structured and rigid, and spontaneously form structures, again, that are easily found in enzymes. So for all these reasons, I believe that amino acids were the way that life started. And the conditions, the physical conditions of the Hadean era systemically assisted amino acids to do all of these things in the cyclic actions that occurred in the oceans, thanks to the gradation of the oceans, thanks to the carbon dioxide content of the atmosphere at that time. So the next videos, I will be explaining in detail each reason on their own in their own video, and hope you enjoy them.